Okay, we are going to go ahead and start on Chapter 8, Logical Functions and Selection Structures, also called if statements. So one way to think of a computer program, and not just MATLAB, is to think how they're organized. Everything we've done so far has been what's called sequential, where you just list commands and they're executed in the order listed. Selection structures let us branch things. The other kind of structure we're going to be talking about soon is a repetition structure, which allows us to repeat things. These are called control structures. So sequence is a kind of control structure where things just are executed in order, one then the other then the other. Selection structure is a kind of controlled structure where it has a branch choice. If a condition is met, it'll do one thing. If a different condition is met, it'll do something else. A repetition structure, also called a loop, causes a group of statements to repeat. So we have seen before some relational operators. Let me go ahead. I'll be switching back and forth between windows here just to show you the textbook. So we've seen some relational operators. Less than, less than or equal to, greater than equal to. We've seen those before. We've seen is equal to. The tilde equals is not equal to. This is something that changes a lot depending on which language you're using. This is what MATLAB uses. A lot of other languages use exclamation mark equals for not equal to. So comparisons can be either true or false. So let me go ahead and swap back to MATLAB window. Okay, let's say I have two variables. I'll call x equals 5, y equals 1. So x and y are defined. I can say x less than y, and it returns logical 0. Logical 0 means false. X greater than y, logical 1 is true. I think we've covered this before. You can also do it as whole vectors, so like x equals 1 to 5, y equals, let's say, if we do x plus 4 like that. Where is x less than y? Everywhere. Where is x greater than y? Nowhere. If I do x equals 1, 2, 3, 4, and y equals 5, 2, 7, 8, where is x equal to y? Only the second position where they're both 2. So that's just a quick look at that. I also want to take a quick look at what's called flowcharts. So flowcharts are covered in section 8.2. We're not going to spend too much time on it, but it's still important to know it. These are the symbols used in flowcharts. An oval is used to indicate the beginning or the end of a section of code. A parallelogram is used to indicate input or output. Diamond is a decision point, and a rectangle is a calculation. So for example, if we are converting miles per hour to feet per second, this would be its flowchart. It's sequential. You start, define a vector of miles per hour, calculate it, combine it to a table, and then output table, and end. As we get more complicated programs, flowcharting might be useful. We'll be doing that some on and off in class. Okay, let me switch back to MATLAB again. There we go. So logical functions. I think some of you may have seen this before, something like find. So I can do something like, let's say I've got x equals rand I 20 size 1. So list of 10 numbers random between 1 and 20. And let's say I want to make a list of, I'll call it at least 10. So you can do something like x greater than or equal to 10, and it will tell you yes, yes, no, yes, yes, no, no, yes, yes, yes. But I can do something like this, at least 10 equals find x greater than or equal to 10. And this will give you the positions, a vector of the positions. So this logical array here, where you just do x greater than or equal to 10, it just says it's the same size. Each one says if it's true or false. Find will tell you the positions where that's the case. So now I can do something like x of at least 10, and that gives you only the values that way. You can also do something like x of x greater than or equal to 10, and it does something similar. I'm going to pause for just a moment. Okay, I think we're back. Sorry about that. I had to check some things. I didn't want it to eat up the time. We're going to go ahead and skip to section 8.5, the if statement, selection structures. So make sure it's pointing to the right thing. Yes, okay. Clear CLC. So the if statement is what lets us branch things. So let me give you a really simple example. I will go ahead and make a new script. Remember, script runs by itself. A function is called. So I'm just going to make a script. This is going to be showcase of if statements. So for example, I can do num equals input, enter a number. If num greater than 0. Notice when I hit enter, it automatically tabs. Disp, I'll use fprintf. Fprintf, you entered a positive number. Remember that backslash n is line break. Just do end. When I type end, it automatically untabs. So I'm just going to run this pretty simple one. I'll call this if showcase.m. So if I run this, ask for a number 6. You entered a positive number. Run it again. Negative 12. Nothing happens because this is a false. This is false. If this is true, it does what's inside the if. If it's false, it does not do anything. So let's go ahead and add to that. So basic if else. It's easier just to go as I go along. And again, you can pause at any point to copy the code down to try it yourself. In fact, I recommend pausing to copy the code to try it yourself. I'm going to change this now. Else fprintf, the number you entered was not positive. End. The end here, notice when I highlight end, it briefly underlines if and else. End goes at the end of the whole thing. If you put end, I'll show you what happens if you put end before the else in a minute. Enter number 6. You entered a positive number. Negative 10. Or negative 11, sorry. The number you entered was not positive. If this statement is true, it does what's inside, and once it's done with what's inside, it jumps to the end. If this is false, it looks for an else. Else happens if this is false. If I do that, think it'll just give me an error. Yeah, illegal use of reserved keyword else. Else can only happen after an if. If you already did an end for the if, you cannot do else. So that's the basics of else. We're going to add one more thing. That's called else if. Else if num is equal to 0. The number you entered was 0. Else fprintf you entered a negative number. Okay. Now in this case, if the number we enter is positive, it'll say so, skip to the end. If not, it checks else if. Else if is one word. If it's equal to 0, it'll do this, skip to the end. Else is our failsafe. It's basically if it fails all of the ifs along the way, it'll do the else. Enter a number, 5. It's positive. 0. The number you entered was 0. -9. You entered a negative number. Now, else is optional, even if you have an else if like this. If I take the else out, I just do if, else if, it'll be like that first if, where if it's true, 6, positive. Okay. 0, 0. But if I put a negative, there's no else at the end, so it just does nothing. So elses are optional. You don't always have an else. Sometimes you want to do something if the condition is true and just do nothing if the condition is false. And that depends on your particular application. I'm going to switch over to a brief example here. Not that way. This way? That way. Okay. I'm new to switching windows using the recording. So here, this case is if the age is less than 16, this is for getting a driver's license. It'll say, sorry, you have to wait. If your age is less than 18, you may have a youth license. If you're between 18 and 70, this is, of course, not standard, but this is particular for this example. If your age is less than 70, standard license, so between 18 and 70. Else, if you're over 70, you need a special license. So this particular case, this is the flowchart for it. If age is less than 16, display this and jump to the end. If this is false, else if, check this. Is age less than 18? Yes, jump to the end. Else if, is it less than 70? Display this, jump to the end, final else. Notice that if, in this case, if I put in age of 17, or say 14, 14 is both less than 16 and less than 18, but if it succeeds the first one, it doesn't check the second one. So this is useful for a tiering structure where I can do, like, let's change my, instead of it being just positive, 0, negative, let's say if num is, let's say, you usually want to go in order in one direction. So this is like a grade scale. If num is greater than or equal to 90, for an F, you got an A. Else if num greater than or equal to 80, you got a B. And so on. You got a C. else if num. Actually, in this case, we're in engineering. If you're in engineering, you have to have at least a C in classes to continue on. Else f printf. Please try again. In major engineering, these don't really count. Out of major, it's usually fine, but in major, it doesn't. Enter a number. 75. You gotta see. I forgot the line breaks. Bum, bum, bum. There. 75. C. Run it again. 92. A. Now notice 92 is greater than 90 and greater than 80 and greater than 70. It doesn't matter. If statements just check the first one that's true. So the order matters. You can't just do like a greater than 70 and then a greater than 90 and then a greater than 80. You have to be in order. So it checks this. If this first one is true, it does its statement and it doesn't even bother to check the rest. That does sometimes mean if you have an error in here and it might not show up until you actually go there. Oh, I'm sorry. I forgot to switch back to MATLAB this whole time. Let me do that. Let me clear and rerun this. So here's the statements. If num is greater than or equal to 90, you got an A. Greater than or equal to 80, you got a B. Greater than or equal to 70, you got a C. Else, try again. Let me run this a few times. 75, you got a C. 97, you got an A. And as I was saying, 75 is greater than or equal to, or 97 is greater than 80 and greater than 70. But this is the one that happens first. It does this. Else only happens if this is false. This else only happens if this is false. This else only happens if this is false, and so on. That is the basics of if. Let me check something really quick. And if is something that's the basic of it is really simple, but you can do so much with it. Scrolling back up. The other one I'm going to talk about is the switch case statement. So let me make a new script using switch and case. I'll save this as switch showcase. Clear CLC. Switch is similar to if then, if, else if, else if, else if, else. However, switch is useful for things, whereas if is useful for things that might have ranges or different conditions. Switch is useful if you've got several things that you're checking equal to. So let's do, for example, the recent test. I don't know if you guys saw when I passed out the MATLAB part of it. I used a dice roller because I had 3 different ones, and I just used a random roller to decide which one you got, A, B, or C. So let's do that. So dice roll equals rand I 6 1. So again, if you're not sure what that will do, you can test it here. There we go. 6 6 3 5. It's a random integer 1 to 6. I can do something like this. Switch dice roll case. I actually forgot to do the double. Forgot how to do the double one. Well, let's do it separate ones first. Sorry, that's my mouse scrolling my notes. Case 1, fprintf test A. case 2. Also got test A. Case 3, got test B. Case 4, also got test B. Case 5, got test C. Case 6, got test C. Otherwise, you should never see this. End. Okay, notice all the tabbing here is automatic in MATLAB. And it's nice and neat. It might be a little bit neater than nested if else's. Test C. Let me actually display the dice roll. Dice roll 1, test A. 6, test C. 6 is C. 5 is C. 3 is B, and so on. I could do something like manually setting it just to show you. Whoops, wrong. If I do dice roll manually to be 7, just to show you what that otherwise happens, you should never see this. But that's the use of case. Case is for, this is the exact same thing as, let me write this down. I actually want to check something really quick. I think it's with a comma. Can I do that? Is that the case? No pun intended. Yeah, if you put a comma, it messes up. Okay, so case is only for single things. Can I do double things? I forgot to check. I don't think you can. Let me pause and I will check that really quick. I'm back. I just had to check it. So this is how we do it. Let me undo the change I made while I was testing it out. You know, sometimes I gotta test things out. If you want to do multiple things, it's curly brace and separated by comma. So I can do this. Get rid of that case. This can be case 3, 4. Like that. Get rid of case 4. This is case, curly brace, 5, comma 6. Okay. Now when I run it, dice roll 6, test C. 1 is A, 3 is B, 3 is B again, 5 is C, 5 is C, 2 is A. So that's how you do multiples, curly brace. If you look in the book, it does examples using text also, so you can do that. But that is the use of if and switch. I'm going to go ahead and end the recording, and hopefully when I go to upload this, I will also have available the next lab for you guys to work on. So have a good day.